As you can see, the prototype works really well. In this video, I will turn it into a proper circuit. But first, let me explain how it works. This is the light sensor, a light-dependent resistor, or LDR for short. Unlike a fixed resistor like this one, the LDR's resistance changes depending on how much light hits it on the top. Those little tracks, they respond to light. If I hook it up to a multimeter, you will see the resistance change when I shade it. You see, light on it, low resistance, cover it, high resistance. Here is a graph to make that clearer. Alright, now we pick a light level, or really a resistance level, where we want the light to switch on and work from there. We need to compare the LDR's resistance to the fixed one. We do that by combining them into a resistor divider, like this. The top resistor is our LDR and the bottom one is the resistor we are comparing it to. I chose simple resistor values to keep the math easy to follow. A resistor divider chops the voltage up in a linear way. To get the midpoint voltage, first divide the top voltage by the total resistance. That gives us the voltage drop per ohm. Then multiply it by the bottom resistor. And that gives us the voltage drop over the bottom resistor, which is also the voltage at the midpoint. So if the top resistor, our LDR, has a lower resistance, then the midpoint voltage will be higher. And if the LDR has a higher resistance, the midpoint voltage will be lower. Back to our LDR resistor divider. Now we know what to do. When the midpoint voltage goes above 2.5 volts, we know it gets dark, so turn on the lamp. And when it drops below 2.5 volts, it's light again, so we turn off the lamp. We now need something that can look at our voltage and decide if it is above or below 2.5 volts. For that, we use something called an op-amp, short for operational amplifier. Do not worry about the name, all you need to know is this. It has two inputs and one output. If the voltage on the positive input is higher than the negative, the output goes high. If it is lower, the output goes low. We use an LM358. It has two of these op-amps in a single chip. It can do a lot more, like amplifying signals and making oscillators, but we are just using one op-amp as a simple comparator. Let's hook it up. Power goes to the top right pin. Ground to the bottom left. The positive input connects to a 2.5 reference, which is also a resistor divider. The negative input connects to our LDR voltage. And the output goes to an LED with a resistor. Now the output goes high when it gets dark and low when it gets light. Perfect.